Gas metal arc welding, filler metal classifications. Gary Pace, PE, welding engineer, Katy, Texas. So why do we care about filler metal classifications? Can't we just grab something, a coat hanger, and go from there? No. Real world welding doesn't work like that. So when we're talking about a filler metal classification, it's going to give us a hell of a lot of important information. Our strength, chemical composition, what welding process we're supposed to use this for, welding positions, shielding gas requirements. Hell, it's going to give us information on diffusible hydrogen, which if you're doing kind of some upper level stuff, that's going to be important in the intended applications. So if we're doing big kid welding stuff, we really need to know something about the classifications because welding filler metal is not just welding filler metal. So for the specifications for this, there's a couple of main specifications that are written by standards organizations in the U.S., and one of them is the American Society of Mechanical Engineers. They put out the Boiler and Pressure Vessel Code. Well, they put out Section 2, Part C, and this is the specification for welding rods, electrodes, and filler materials. This gives you all the, if you're a outfit that a company that is making filler material, this gives you the recipe and the specifications that you have to follow to be able to produce the metal, the filler metal, to meet the specifications for the various applications for constructions of boilers and pressure vessels. These give you all kinds of detailed information about the chemical composition, the mechanical testing, mechanical properties, and other characteristics to produce the filler material. So this is basically a how-to recipe book for how to construct filler material. And not really how-to, but the criteria that it needs to meet to be fall into a specific specification. So the American Welding Society also prints out a bunch, and there's a lot of overlap between the American Welding Society and the American Society of Mechanical Engineers. So, but each group has its own specifications for filler materials. But like I said, there's a lot of overlap. And I don't know what the nuances are between the differences between the two. I'm sure there's some, but it would probably take some digging to find. So in ASME Section 2, Part C, these specifications are really important, if not essential, for making sure that the welding materials meet the required standards. So, and that they're suitable for the intended application. So, this is just a lot of information that, you know, if you're looking to figure out what filler material you need, this can be a great source for providing you technical information. You know, engineers, welders, inspectors refer to these specifications so that they can make a selection and get, you know, an appropriate filler material for the job they're doing. And it would be based on some factors like, you know, the base material that you're going to weld, the welding process, and, you know, the requirements of that project. So that's what's contained in these specifications. It's just a lot of data and a lot of information. So this is what our carbon steel gas metal arc welding filler material looks like. As I've stated before, it's covered with copper. The copper is to keep it from rusting and also acts kind of as a lubricant as it's going through the welding gun liner on its way from the spool to the end of the weld gun where it will be melted. So with gas metal arc welding electrode, this is our classification system. Our first two letters, the E and the R, tell us that this is an electrode or a rod. We can use it either for gas tungsten arc welding as a rod. Rod means we don't run electricity through it. The E means we run electricity through it. The 70 is the tensile strength, And then the S tells us it's a solid cord wire. And then there's the usability and performance there at the end. What additional information? So when we're talking about the 70 there, we're talking about the tensile strength. The tensile strength that it's required to pull that material apart, 1 square inch of it. I'm operating in English units. So here would be your chemistries. So within the specification, like ASME Section 2 Part C, for each filler material, there would be um, a little table like this that tells you the chemistry for that particular filler material. So on this one, it's telling us what I've got highlighted in the column is the silicon content, for that particular filler material. So for our ER70S3 there in the red, 0.45 to 0.75 would be our silicon content. So, and you could read through the rest of this, but it just tells you all of the chemical requirements, the chemistries required for these filler materials. So here we have the types of filler materials that we can use for flux-core or gas metal arc welding. The first one we have is a solid wire. And we just saw a picture of that. It's just solid. There's nothing inside of it. The next type we have is a metal core composite. So this one is kind of a combination between a flux core and a solid wire. So all it has in it is a metal powder, basically iron filings. It's just really fine ground up metal in there and some alloying elements. But this is called a metal core wire. So it's got an outer sheath, and then on the inside it's got a bunch of iron powder or different metal powder. And then when everything gets melted, this stuff gets deposited into the weld joint. And then on the last one here on the right side, we've got a flux core, which has a flux on the inside and alloying elements and whatnot, and then it's got a steel sheath on the outside. So this is our three options. We've got solid, metal core, and flux cored filler materials. And on these, depending on what you got going on, the metal core people, if you call them and ask them, they're going to give you all kinds of information on their product line and why it's the best thing. And, the same for flux core or the solid core people. So here we have gas tungsten arc welding and gas metal arc welding with carbon steel. We already looked at this. We've got the ER, electrode and rod, and then we've got the tensile strength. And then we have the S that tells us it's a solid wire. And then the 2 tells us the specific chemical composition that's going to be laid out in the specification. And here's another look at the classification for solid steel wires. Pretty much tells us the same information, but this is just a different layout for explanation of that specification or that nomenclature. So here would be gas metal arc welding, gas tungsten arc welding, stainless steel. So here we have ER. And with stainless steels, we don't do tensile strengths. As far as the identification of the filler material, we just use the chemistry, the trade name, the type of stainless steel. So here we have electrode rod, and then the 308 is an AISI type 308 stainless steel, and it's a low carbon steel. So then when we get to weird things like nickel alloys, we go ER. This is an electrode or a rod. We can use it either as a gas metal arc welding filler material or a gas tungsten arc welding filler material, because the rod would mean we're not going to run electricity through it. And this tells us a specific formula. So this nickel, chrome, moly, and it's the third one. It's the third chemical composition within that same group. So with metal cord electrodes, one of the things we have is we've got E70C, that fourth, that fourth letter in this designation is going to tell us what kind of filler material. It's going to designate the product form. So in this instance, it is a metal core. But other than that, it's pretty much the same as the ER, the electrode rod, other than this is just a straight electrode. But it gives you the gas type, the usability performance, and also the hydrogen content, which is really important in a lot of industries because we don't want to have hydrogen cracking. We want to minimize the amount of hydrogen we have in the weld puddle. Here's one for composite steel wires, E70C. That fourth letter in the designation tells us it's a cord wire. The 6M is going to tell us the chemical composition of the deposited weld, and then it's telling us, what shielding gas we should use, and then the diffusible hydrogen designator there at the end, the H4. So with that H4, a lot of times you'll see it, but sometimes you won't. So Flux-cored arc welding stainless steel electrodes. So this one, we don't have a tensile strength in it. You'll notice that it's E308. So that means it is an electrode. It is 308 stainless steel. And, the L means it is low carbon. The T is it's tubular. And then the 1 tells us the position. So in this one, it's all position. And it identifies the shielding gas requirements. So our key takeaways here are the filler metal classifications are in the United States are generally the American Welding Society and American Society of Mechanical Engineers. There's a heck of a lot of overlap on these different specifications, but there might be some differences because, well, each one of them's got a specification or book of specifications. So the classification is going to tell us information about strength, chemistry, our usability, what are we going to use it for, and the performance. And we've got a whole laundry list of different welding processes that use different filler metal classification systems. For gas metal arc welding and gas tungsten arc welding, it's the same classification system. The product just comes in different forms. For gas metal arc welding, it comes in a spool, and gas tungsten arc welding, it comes in cut lengths. And you can see for ER308L, that's stainless steel welding wire for gas metal arc welding. And then if we've got a T on it, it's, if it's just an E and a number, well, that's going to be a flux core. And then if it's got a C in it, it's metal core. And then we've got some nickel alloys. They've got a weird system there with the nickel chrome moly 3 whatever. So, but anyways, this is our classification system and how we use it. Questions, comments, thoughts, concerns? Gary Pace, PE Welding Engineer, Katy, Texas.